Welcome. Today, we'll find the derivative of y equals inverse hyperbolic tangent of the square root of x. Let's start by writing out our function. To solve this, we'll need to use the chain rule since we have a composition of functions. Let's recall that the chain rule states that the derivative of a composite function is the derivative of the outer function times the derivative of the inner function. In our case, the outer function is inverse hyperbolic tangent, and the inner function is square root of x. First, let's recall the derivative formula for inverse hyperbolic tangent. The derivative of inverse hyperbolic tangent of x is 1 over 1 minus x squared. Next, we need the derivative of the square root of x, which is 1 over 2 times x to the negative 1/2 power, or 1 over 2 square root of x. Now, let's apply the chain rule. We'll multiply the derivative of inverse hyperbolic tangent evaluated at square root of x times the derivative of square root of x. Let's simplify the denominator of the first fraction. Square root of x squared is just x, so 1 minus square root of x squared becomes 1 minus x. Now we can combine these fractions by multiplying them. When we multiply fractions, we multiply the numerators and denominators separately. And this is our final answer. The derivative of inverse hyperbolic tangent of square root of x is 1 over 2 times square root of x times quantity 1 minus x. Remember, this derivative is only valid for x less than 1, since the inverse hyperbolic tangent is only defined for inputs with absolute value less than 1.